Okay, let's dive into this. Motion. It's happening all around us all the time. But have you ever stopped to think about the hidden power in it? You know, what makes some moving things totally harmless and others, well, incredibly dangerous? Today, we're going to pull back the curtain and uncover that secret ingredient.
I mean, think about it for a second. Why is a leaf gently falling from a tree completely harmless, but a cyclist, even one not going that fast, can be a real hazard? It's such a simple question, right? But the answer gets at something really fundamental about how our universe works.
Because here's the thing, the key isn't just about speed. Both that leaf and the cyclist could be moving at the exact same speed, but one has zero impact, while the other, well, it has a serious crushing power. So if it's not just speed, what is the missing piece of this puzzle?
Okay, let's run a little thought experiment. Picture a flimsy cardboard wall. A little toy car rolls up to it at, say, 5 kilometers an hour. What happens? It just kind of bounces off, no big deal. But a real truck, at that same exact speed, it doesn't even slow down. It plows right through it. Same speed, totally different outcome.
Well, this hidden power, this crushing power we've been talking about, it has a name in physics. It's called momentum. And it turns out it's all about two key ingredients working together, an object's mass and its speed. So let's break those down one by one. First up, we've got what I like to call the heavy hitter of the pair, an object's mass. This is really just about how much stuff something is made of. How hefty is it?
Imagine a tiny little ping pong ball rolling slowly towards a bowling pin. It's probably just going to tap it and bounce off, right? But now, picture a giant boulder rolling at that exact same slow speed. Whoa, it's going to send those pins flying. The only thing that changed was the mass.
So here's the deal. Mass is simply the amount of stuff packed into an object. And when it comes to momentum, the more mass something has, the harder it is to stop once it gets going, even if it's moving slowly. It's got more oomph, more force behind its motion.
But, you know, mass is only half the story. Now let's talk about its partner in crime, speed. The speed demon, if you will.
Let's think about a single bullet. If you were to just toss it by hand against a wooden board, what happens? It just clinks off and falls to the ground. Harmless. But if you fire that exact same bullet from a rifle at the same board, bam! It punches straight through.
Think about that. The mass of the bullet was identical in both cases. The only thing that changed was how fast it was going. And wow, did that speed make all the difference.
And this is just a perfect way to understand that second ingredient. Speed is just how fast something is moving, but cranking that speed way up can give even a really small, light object a huge amount of momentum. It can make it incredibly powerful.
Now, what's really fascinating is when you see how these two factors, mass and speed, can combine in some pretty extreme ways. For instance, what happens when you have an absolutely enormous mass, but its speed is almost zero?
You know, there's this great quote that I think just nails it. Momentum is the stubbornness of an object to stop. I love that. Stubbornness. It's like the object just refuses to change what it's doing.
So, let's look at the ultimate example of this. A massive ocean liner docking in a port. I mean, to the naked eye, it barely looks like it's moving at all. It's just crawling. Its speed is practically zero.
But here's the catch. While its speed is basically nothing, its mass is, well, it's just mind-boggling. 200,000 tons. That's the other side of the momentum coin right there.
And when you combine that ridiculous amount of mass with even that tiny, almost invisible speed, what you get is an absolutely unstoppable force. If that ship bumps into the dock, it doesn't just tap it, it crumples solid steel like it's a soda can. That, right there, is the power of momentum.
So, let's just break this down one last time and really visualize how these two ingredients, mass and speed, work together. Think of it like this. Mass and speed are equal partners. The actual physics formula is super simple. Momentum is just mass times speed. That's it, which means you can have a huge object moving slowly or a tiny object moving crazy fast, and they can have the exact same amount of momentum. It's the combination of the two that really matters. All right, so let's wrap this up. What's the big takeaway here? Well, momentum is really just the oomph of a moving object. It's that powerful combination of its mass and its speed. It's that stubborn tendency for things in motion to stay in motion.
And as I've seen, that's the secret for why a tiny bullet can be just as destructive as a massive ship.
So, now that you can see this hidden force all around you, here's a question. The next time you see something in motion, don't just see how fast it's going. Try to see its momentum. From a gentle breeze to a crashing wave, our world is just a big dance of mass and motion. Where are you going to spot it next?